Thank you, Sivia, and thanks everybody for joining us. Welcome to another Cloud Security Masterclass. Today we're going to be digging into developing a strategy to secure your infrastructure as code. We've got my colleague, Josh Stella, here to walk through that with you. So without further ado, let's get on with the agenda. So Josh is going to cover some basic concepts about infrastructure as code, cloud security, things like policy as code, shift left, etc. And then we're going to get into the steps for developing your cloud infrastructure as code security strategy, assessing your current state, etc. And then we'll touch on some implementation and optimization, and get to your Q&A at the end. But as Sivia said, if you have questions or comments at any time during this presentation, please do pop those into chat, and I'll make sure that we address those with Josh. Next, this is hot off the press. Get the copy of the Engineer's Primer on Cloud and Infrastructure as Code Security 2021. This is sort of an update to the Engineer's Handbook that we put out last year, but all the sections are revised, and we've added a considerable amount of new content, primarily focused around infrastructure as code security. So get that at fugue.co/primer. And then finally, if you haven't gotten your copy yet of the State of Cloud Security 2021, we partnered with our friends over at Sonatype to produce this. This past spring, we surveyed 300 cloud security professionals, engineering professionals, to understand kind of what they're going through, what they're dealing with on the cloud security front, challenges, what they think they need. It's really interesting, actionable insights in there. So get that at fugue.co/report. So now that we've got that out of the way, let's get to why we're all here, and see if we can introduce Josh. Hey, Josh, are you there?
I am here, Drew. How are you doing today?
I'm doing great.
So we're going to cover both the what can be done with infrastructure as code security, what can't be done as infrastructure with infrastructure as code security, and you need to deal with some other way. And as this topic is getting much more popular now, how it relates to what you've already been doing in cloud security. Okay. All right. So why we're all here on the topic of doing cloud security with infrastructure as code. Our engineers could be moving faster, right? Moving fast is central to digital transformation, whatever you want to call it, to adapting to the modern world of software development. Speed, velocity is everything. And we want our engineers to be going really quickly in a secure way. And so with cloud and IAC approvals, audits, remediations, these things can take weeks or months. If you're not automating your security processes, and with policy as code and infrastructure as code, we are talking about automation of your security practices. If you're not doing that, doing these things manually is very slow and creates a lot of friction and rework in the process. So your engineers, you want them moving fast, and you want their energy spent on creating more business value, more value for your customers, right? That's why we exist as organizations, as businesses, is to create value for customers. Security is something we have to do along the way. So a half of cloud engineering teams, according to, we do a survey annually, and Drew talked about it, the State of Cloud Security survey, of 300 organizations that are operating at scale on the cloud. And this is where we're finding these data, and I'm going to go into some more from that survey as well. But half of engineering teams out there on cloud are spending 50 plus hours a week just on infrastructure as code security, and another 50 plus hours a week on runtime security. So that's almost a full-time person, right? In our business, 50 hours, it's, 2/3 of a full-time person, something like that. All right, but you want all this to be happening without exposing yourself to risk, right? Without breaking rules. You want to be able to control for your security concerns while you're doing these things. So in our survey, 52% of respondents cited a lack of awareness of cloud security policies. Now, I've spent 30 plus years building systems. I'm before being a founder, CTO, CEO now, I was a software developer and software architect for many, many years. And very often when it came to security, a lot of those years, by the way, spent building systems in national security contexts where we had very rigorous security policies we had to follow, et cetera, around, you know, NIST 800-53 and similar. And this idea that you can train people to solve this problem of being aware of what they're doing from a security perspective, I believe is wrong. If you look at NIST 800-53, there are over 1,800 rules, controls in that one compliance standard, which is the basis of a lot of what we talk about in security. So asking people to memorize phone books is doomed to failure. You do want to train people, but you can't expect them to know all of this. Humans are remarkably bad at remembering long lists of things. We are not evolved to do that. It's why phone numbers are broken up into, 3 digits and 4 digits. Most humans can only remember about 7 things at a time. And so we're very bad at doing something like memorizing a giant guidebook of security policies. Therefore, don't ask your people to do that, and don't blame them if that is what you're expecting them to do. It's unrealistic. And over a third of these respondents, by the way, there's good news on that front, which is automated tooling and policy as code means that your folks don't have to do something humanly impossible. And so that's nice, because you know what are great at remembering tons and tons of details and applying them consistently are computers. They're really good at that. And so in this, we're going to leverage that to provide that security. So, over a third suffered a cloud breach or leak in the past year that they were aware of. And I want to point out, as we do a lot of security, a lot of research into real world hacks and breaches, there is a lot of reason to think that many, if not most of these, don't just go unreported, but go unnoticed. So, you know, you can see major banks and even security software companies getting breached and only knowing they've been breached when somebody brags on social media or an extortion attempt is made, etc. So in our survey, over a third knew about a leak or breach. All right. So security in this world really becomes the rate limiting factor. We've now spent over a decade with cloud computing massively accelerating the ability of development teams to go fast, and security teams have honestly been a little bit left out of the fold. And so we believe at Fugue that policy as code, as it applies to infrastructure and runtime, infrastructure as code and runtime, is the right answer to this problem. Okay, let's go through some basic concepts. What is infrastructure as code? It is code that it allows you to express, build, and manage cloud resources, cloud infrastructure. We're not just talking about IaaS here. I wish everyone would forget about the IaaS, PaaS, SaaS thing. There really is no clear line, especially between IaaS and PaaS. So we're talking about cloud resources, whether they are platform style resources or pure infrastructure style resources. With infrastructure as code, we can define those things and manage those things through it says here, Drew and I struggled to come up with a good term, but machine readable definition files. What we're talking about are configuration files, code, if you will, that is read and used by a computer to automate these processes. Okay, so the human interaction is primarily by authoring that code. It's extremely popular. Examples are Terraform, CloudFormation, to some degree, things like Ansible, Azure Resource Manager on the Azure side. But that's what we're talking about with IAC. Now, policy as code, a lot of people think policy as code only attends to infrastructure as code. That's not true. Policy as code, you can implement whether or not you have implemented infrastructure as code. It is actually an earlier step you can take. And it also can apply to all those things that you've built without using infrastructure as code. It also applies to the infrastructure as code itself, okay? So what policy as code is about is expressing and enforcing policies using, in this, again, machine readable definition files. We're using code to have the computers enforce the policies. Drew, I think you're on mute.
Oh, I was. Rajat says maybe manifests would be a better word for policy as code, etc.
You know, it's interesting you bring that up. So manifests are more typically infrastructure as code. So a manifest, if you're not familiar with it, but thank you, Rajat, it's a good point. If you look at a Terraform template, it is very much like a manifest. In Kubernetes, these things are called manifests. Policy as code done well is not in the form of a manifest or a JSON file or something like this. It is in the form of code, actual code. So what we're going to be talking about today, our preferences for Open Policy Agent, which uses a query language called Rego. So your policies aren't manifests, they're more like queries, but that's getting down in the weeds. But thank you for the suggestion, Drew. I think for IAC next time, we should say manifests. I like that. So the term shift left, this is really about moving security functions earlier in the software development lifecycle. I don't love this term because it kind of suggests if you move them earlier, you don't need to keep doing them later in the SDLC, and that's wrong. That's not true. You need to do both. So shift left is more like cover left or spread left. You still need this stuff on the right. Okay, and DevSecOps, when we talk about that, we're talking about integration of security into the software engineering process itself. This idea of putting dev in front of things, it goes back to the kind of Mark Andreessen quip that software is eating the world. If humans can put an API on something and write code for it, we're going to, and that's for good reason. So security is now turning into a software engineering discipline much more than it has been in the past. And by the way, normally in these master classes, I spend most of my time at a whiteboard and at a keyboard. This one is about developing a strategy, and so it is mostly slides, but we'll try to keep it interesting. Okay, what are the problems we're trying to prevent when we employ security with IAC, when we employ security with infrastructure as code? So if you think about infrastructure as code as being kind of manifests that define what you're going to create or how you're going to modify it, what you want to be checking is to make sure those are the results of those are secure. So the mistakes that you're trying to prevent are configuration errors from a security perspective. Every cloud breach I'm aware of in the history of cloud breaches is due to misconfiguration of cloud resources. There might be other contributing factors, but that is the primary attack surface. So this is a worthy thing to try to prevent, right? So this is again from our State of Cloud Security 2021 survey, the kind of list of things that are top of mind, that are misconfigurations that our respondents see and that they're worried about. And the one with the highest number here, obviously these are not exclusive, you could choose more than one, is identity and access management. And boy, is that true. IAM actually forms the principal network in the cloud, and your ability to secure that is absolutely critical. But also things like security group rules, that's like firewall rules, ingress and egress rules. We also have here object storage access policies, things like S3 bucket resources. This is a great example of something, S3 bucket policies. They're called resource policies. That's a great example of something that you should be checking in your IAC if a new S3 bucket or equivalent is being built on a cloud, to make sure it has some controls on what can access it. Okay. So IAC security, its potential and limitations. And I'm looking at the clock here. We're almost halfway through. I hope to get through everything in this. If not, we will have a follow-up. But we're going to cover a lot of great ground today. So there's a misconception out there. So Fugue, actually, we invented the idea of policy as code for infrastructure as code. We have fundamental patents on this. So we've been doing this for years now, policy as code for IAC. And now it's finally something the market is understanding, and it's getting popular. And as often happens, people have perhaps a overly expansive view of what IAC security can do. There are things it's great at, and there are things it just simply can't do. So things it's great at, avoid deploying misconfigurations. Very typically when a customer first tries out Fugue, they'll find a ton of stuff over years of cloud adoption that they have created that has security vulnerabilities due to misconfigurations. So with IAC checking, you can prevent new problems entering. You can stop digging the hole. Okay, so it is largely a preventative technique, and that's great. We love prevention. So it will, with policy as code automation, you will be able to develop and deliver secure cloud infrastructure and apps much faster, because you don't need a human in the loop. You can have a compiler and an evaluation run in your CI/CD pipeline by a policy as code checker for your IAC to tell you whether or not it's safe and to approve it or not approve it. So it really speeds things up. It allows you to find and fix problems earlier, cheaper, and faster. Cheaper and faster might be synonymous in a lot of ways, but what developers who are writing code are used to and want is not to memorize phone books. None of us can do that. Very few people. It's a bad idea to expect it. Instead, our tools as programmers tell us where we make errors. Okay, and that process, that automated process of the tools telling us where we made an error. In this case, it might be you have an unsafe policy on an S3 bucket, and that comes back as feedback right in the loop when you're writing that Terraform template. Then this stuff is gonna go much faster. And by the way, this is the best kind of training for your engineers. This is better than classroom training. Put a tool in their loop, and I'll show you an open source one that we have that you can download today for Terraform, CloudFormation, Kubernetes manifests, and have that feedback loop begin so that those engineers are seeing what they're doing that's wrong. That is the best training you can give them. Obviously, this can automate approval processes if these policies on IAC are agreed to. You can avoid rework, getting to the end and the security team saying, no, you can't deploy this. You have to go back to the beginning and rewrite how you built the network, things like that. And I already made this point, but build security awareness and knowledge with your cloud teams. So there's a lot of great stuff you can do with IAC security. Everyone should be doing this. Everyone using IAC should be doing this. And as I said, to get started, there's free and open source tools out there. So there's really no reason not to. So the list of things, a partial list of things it cannot do, that it cannot help you with. It cannot go out into the runtime environment, the deployed resources, right? Whether or not they were deployed using IAC, and tell you if there are misconfigurations, right? It cannot tell you what is running in any kind of definitive way in your cloud. And I've had people tell me for years now, oh, we do everything through IAC and only changes get made through the CI/CD pipeline. I have never once seen that to be true for a number of reasons, even among those most convinced that they are doing that. And the reasons are manifold. One is speed. Remember back at the beginning, I said velocity trumps everything. Speed is the most important thing. Well, if you have a system that's down, it is slower to go and modify IAC code and run it through a CI/CD pipeline than it is to log into a console and get it running. And I guarantee you, when the sales team is trying to close out a quarter and something's down, the deal is going to take precedence in almost all cases over your correct process. Okay, so this is another place where you have to trust but verify. The other aspect of that is there are always things in your cloud environments that are not created using IAC templates. And there are some things in cloud environments that cannot be created using IAC templates. So you're limited in scope with IAC security to the things that are defined via IAC and that have not then been modified post-deployment. So it's really not it's not in any way a definitive source to tell you what your security posture is. What IAC security is telling you are the IAC jobs you ran when you ran them did things according to policy. They are not going to tell you if those things were later changed or if the context in which they were deployed causes them to breach another kind of policy in the runtime. Okay. So a little bit about the SDLC and where we're going to apply security. And I kind of tipped my hat to this, tipped my hand earlier, but the answer is everywhere. Okay. The answer is we're going to put security everywhere because you must. Security is just a domain of software engineering. Okay, it's a domain just like performance. It's a domain like functionality. And therefore, you have to be concerned with it the entire way through. Historically, it's really only been focused on the right-hand side of this diagram of the production stuff. IAC security is allowing you to bring it over into development and deployment as well as production, not instead of production. So in cloud, when we're talking about development, we are talking about application development, but we are also talking about the definitions of the infrastructure on which those applications will run, right? The cloud flipped this on its head. In the data center, you went and procured a bunch of gear, and then you would fit applications into that. In the cloud, there is effectively infinite amount of gear out there at the CSP of your choice or CSPs of your choice, which is usually what we see at Fugue, more than one, mostly AWS and Azure. But your definition of the running infrastructure, whether that's Kubernetes clusters or serverless functions or databases, that's now part of writing code. Okay, that's part of development now. It's not an operational concern that development fits into. I can build a network with an IAC template that's a global network in 5 minutes. And guess what? As a developer, I'm gonna do that, right? If I have that opportunity and the requirements on me are to drive top line if I'm a private sector organization or do mission fulfillment in public sector, I'm gonna do what I can to move as fast as I can. Okay, so in our modern CI/CD pipeline world, deployment is now a very concrete and discrete aspect of the SDLC. Back in the day, Deployment was, we used to go in with Excel spreadsheets, and some folks you might still be doing that. These days, it tends to be driven by CI/CD pipelines, and therefore it's an automated process. It's a repeatable process. It is a hopefully deterministic process. In other words, you know what the results will be when you begin, and they will be the same when you repeat that operation. So here in development, we can use infrastructure as code security in the form of policy as code to give the developer feedback and to tell them where they're making mistakes so that they don't introduce mistakes into the shared code base. But then when we get into deployment, and especially deployment into dev or stage, right, the pre-production world, we can actually fail builds based on improperly secured IAC templates. So that allows us to create a gating mechanism to not allowing mistakes to get into production. But then once we're in production, even assuming that everything has been done exactly correctly with great policy checking through dev and deployment, and it gets deployed to production successfully, there's a bunch of policy checking you need to do there too, both over time to make sure those assets, those resources don't mutate in dangerous ways, but also for broader contextual checking. So what I mean by that, and we're about to get into kind of the process of putting this stuff in place, but I want to cover the topic of, in fact, let's go to a whiteboard for a few minutes here to cover this topic. Great, Drew, are you seeing my whiteboard? I think we've got it.
Yes, indeed.
Okay, so over here on the left, we've got developers, right? And developers are going to be writing IAC templates. Now, one of these might be, for example, for networks. So I'll say net. Let's give the dev a name. We'll call this one Drew. I drew him pretty nicely, so I'll make that Drew. And I'll make this ugly one Josh.
Do me justice.
I'll work on it. So Drew's building the network IAC templates, and I'm building the database for IAC templates, okay? And the way this is going to work is as we go through, so this is the development stage, as we get into deploy, and let's talk for a moment about deployment just to a dev or a dev or test environment, pre-production environment, probably that CI/CD tool, let's call it Circle CI or Jenkins, any of those, are that CI/CD pipeline is going to grab that network template and it's going to go create a network. Basically, actually, let's use some colors here to make sure this is clear. So our network template, we're going to use blue, and it's going to create this blue network. Here, let me just erase this. So it's going to create this blue network, and that network might include the security groups, and it might include the routing tables and all kinds of stuff. It might include ACLs or NACLs, network ACLs, that are being defined from this IAC template. And I may or may not work directly with Drew. Okay. I'm on some other team and I want to deploy a database. So my green database IAC runs through a separate process in the CI/CD pipeline. I'm on a different team. This is very common, by the way, for Drew to be on kind of the central cloud team and I'm on some application team. It's very common. A lot of our customers at Fugue have hundreds of different applications over hundreds of cloud accounts. We manage the security for millions of cloud resources. So we see all these scenarios. It's very common for there to be a team that lays down the network infrastructure and then application teams to deploy stuff into that network infrastructure separately using separate IAC templates. So in this case, I'm going to drop a RDS database inside of this network. Okay, let me do that again. So one question that that might immediately come to mind: can I check the network security of my database at this green CI/CD policy check? Anyone? Can I do that? Can I know when I have this IAC template that's defining the database? Can I know if it's secure from a network configuration for the network it's being dropped into? Not seeing an answer real quick. The answer is no, I can't. The fact is I cannot. Now it can be a somewhat nuanced answer. I don't want to get too far down in the weeds on things like Terraform plan steps and so on, but there are interactions between the different IAC implementations you're going to be using. And frankly, these might be written in different kinds of code too. I might be using here Terraform, and Blue Team is using CloudFormation or Azure Resource Manager, right? They might even not even be the same kind of source code. And this is very common. It's also very common when organizations grow through acquisition, for example. One of our big customers is Red Ventures, who are the New York Times did a story on them recently. It's like one of the largest publishers you probably haven't heard of. They own CNET, they own bankrate.com, they own a ton of these internet properties. And when they acquired CNET was all built on the Google Cloud. They had to onboard massive amounts of that Google Cloud stuff, and a lot of their native built applications are AWS. So there's lots of ways you're going to inherit different IAC code bases and different deployments, and in your security processes and systems need to understand that. Okay, so the other thing that happens here, I'll put another person over here. And this is evil Josh. So this is Josh in red. This is me at 2 a.m. getting that call from the APAC VP of sales saying something's down. I'm trying to close the deal. Fix it now. And I guess what? I go to the console and I tweak the security group definitions just to get it running. And then I go back to bed at 5 in the morning. Well, now this security group does not match, right? Does not equal what is in this template. They're different. This is going to happen to you. So as you get into thinking about IAC from a security perspective and a policy perspective, it's just really important to understand the scope and what it's going to do for you, and not believe it's like a generic silver bullet that will solve your cloud security issues. It is absolutely essential that you do it, but it isn't on its own sufficient to the whole problem space. Okay, so phases of implementing an IAC security strategy. And we've got about 15 minutes left, so I might go a little quick through this, but I really wanted you to understand the problem space, the domain first, what you're trying to solve and what you can and can't solve using these techniques, so that this had any relevance, right? Well, the first thing you're going to do is an assessment process. Then you're going to go through a planning process. Obviously, you're going to go through an implementation, and then you're going to loop that in an optimization loop. So when we talk about assessing the current state, there's a broad range of things that you're going to want to do. One is you need to figure out what clouds are we using, the nature of the architecture that you're deploying to those clouds. You know, are you principally using virtual machines and more of a lift and shift legacy application model? Are you principally, by the way, if you're doing that, you're going to have a lot more manual changes from the console as opposed to CI/CD changes out in the running environment. These have different characteristics and traits to them. Are you doing Kubernetes and containers? Are you doing serverless? These are very different kinds of things to secure. And they actually have very different implementations from an IAC perspective. with Kubernetes, you need to be very concerned about case manifests. With cloud native services, by cloud native, I mean not inside Kubernetes clusters, but cloud virtual machines, cloud serverless functions, etc. That's probably going to be in your Terraform as opposed to your Kubernetes manifest or your CloudFormation. It is really important when you're assessing any kind of new security initiative, including IAC, to understand what you actually have in your cloud environment. That may sound really obvious, but in our experience, it's not. I'm going to just show you here briefly how we try to help with this. This is the graphical console of our product, Fugue. I promised you I'm not doing a sales pitch. I am not doing a sales pitch. I'm just showing you what we mean by being aware of what you have running. So here, Fugue is automatically diagramming as like a Google map, what you have out there running in the infrastructure, regardless of whether it was built using IAC or not. But as part of your assessment process, you need something like what I just showed you to tell you your current state. And then, of course, you need to plan for your organization's realities going forward. In these larger customers we have a very large international systems integrator whose name I can't share with you, who have standardized on Fugue. They have 90,000 employees. How are we considering security policy as it relates to IAC across this very, very diverse spectrum of teams on thousands of different projects, right? So these are things you need to start thinking about. In terms of what you plan to implement using IAC security, and a lot of the stuff I'm talking about actually applies to cloud security generally, but it definitely applies to IAC as well. So you need to ask yourself what policies it says here must you comply with if you're in a regulated industry that is literally a legal must comply with. But you almost certainly have the desire to not be hacked, and therefore what policies do you want to comply with? Do you want to use to help secure your environments? What's the current security and compliance posture? Back to the diagram I was showing you, all those things in red were things with security problems from a policy perspective. What tools do you have in place today? And do those tools support this process of adding left, of shifting left, adding IAC directly to your security practices? Very often the answer to that is no. We certainly do that all the way through the SDLC. Others are trying to, but even if you're using other tooling than Fugue, you need to understand where its limitations lie in that regard. And then, do we understand our blast radius risk? This is something that I'm not sure. It's a term I've been using for many years and thinking about for many years, but I'm not sure it's something that folks tend to think about things in terms of severity. And that's a common practice. Is this a high severity? And high severity often means, it creates an easily exploitable vulnerability and something important. I tend to think in cloud security more in terms of blast radius. Assuming that security is imperfect, what is the most amount of damage that breaching something can do? And how do I design systems in a way that that limits that blast radius, that tries to contain that? And as it says here, your IAM security is extremely important when it comes to blast radius. I'll also point out IAM security is something that your security tools have to fully embrace in IAC, because it's really hard to do it at that stage. Of course, we support that, but it's something to watch out for. Can your IAC policies themselves be inspected during the IAC phase? In terms of assessing the current state, are you doing any IAC? Probably somewhere you are. Whether or not you've chosen to as an enterprise, there are probably folks out there doing Terraform or doing CloudFormation or doing Azure Resource Manager. It's probably in there. You need to know which tools are being used. I would make the assumption that you will never fully know which tools are being used in your organization if your organization is sizable at all, and that you will not be able to control the IAC tools that are going to be used by the teams. I would make the assumption that you have to deal with a heterogeneous environment for IAC because it's constantly changing, and everyone knows developers we're a bit faddish. Okay, we jump on trends, and well, at least some do, and you know, if you're worried about creating, it's kind of like being realistic about people memorizing NIST. Be realistic about people using different policies. Hey, Drew, I hate to ask this of you, but could I please hand the baton to you?
Taking a look at like our cloud engineering and security teams, this is probably going to be different with everybody, you know, every organization, everybody on the call. Do we feel that we have the cloud engineering and security teams on hand to tackle this problem? Do they have the skills they need? Do we need training? Are they overstretched? And it might be very different across departments. It's not unusual to see a cloud customer that has some teams that are really well advanced on their use of cloud and cloud security, and other teams that are really far behind. And you know, there's strategies that you can use to kind of share that knowledge, bring other teams up to speed, kind of, you know, again, create sort of a cloud center of excellence. What's our budget and timing? Usually the timing is as soon as possible. You know, that might be how quickly do we need to bring existing environments into compliance? Do we have new greenfield workloads that we need to get delivered to market? And then what are our future plans look like? And you know, there should be a desire to future-proof as much as possible when selecting your infrastructure as code and cloud security tools and solutions, to make sure not only are you covering your current use cases, but where might you be going, and are the products and tools that you're choosing going to support you with future decisions? Whether, you know, maybe we're on VMs today, but with new applications we want to deploy, we want to choose to go serverless. Will these tools support that effort? You know, maybe we're on one cloud today, but we're looking at, you know, maybe we're on AWS, we're looking at expanding to Azure. What might that do with regards to our ability to keep everything secure? Sometimes that includes M&A activity. You know, we've seen companies that are managing a lot of different environments, each of which were developed by completely different engineering teams prior to acquisitions. It's not that uncommon. Are we planning on new DevOps or SRE approaches and practices? Might we have new compliance or security requirements with regard to existing or future applications? So those are all questions to kind of ask yourself and of your team to understand your current state, your potential future state. Now let's get to the planning stage. And before we do that, there's one kind of mandatory thing that we absolutely believe should be the foundation of any IAC and cloud security solution that you choose, is that it is based on policy as code. If your compliance policies, internal security rules, all of your governance, if that is expressed in human language, on paper, in a Google Doc, wherever, for humans to consume, it is not going to be good enough. It's not going to scale. There's no way your teams are going to be able to cognitively organize all of that and implement it in any kind of consistent way. So policy as code is the only way to get this job done. So some questions to ask when you're kind of in that selection phase for IAC security. First, will it work with the current platforms and tools? It's obvious, we're using AWS or Azure or both, or Google Cloud, Terraform, CloudFormation. Are these security tools going to work with those? Are they going to integrate with our CI/CD pipelines? How will it play well or not with our current CSPM or Cloud Security Posture Management tools? Will that be seamless and kind of interconnected, or will they be two completely separate things, one focused on infrastructure as code, the other focused on the runtime? We've got other tools, SEM, ticketing, analysis tools. How well will it play with that? Do you have the proper kind of integration APIs? The next question to ask is about our cloud engineers, our developers. Will the IAC security tooling we choose help them do better and build correct infrastructure quicker? Is it going to work in a familiar workflow that's familiar to them, in the same way that other tools help them check to make sure that what they're doing is going to actually work? Is it going to work and be in compliance? Will it provide the kind of feedback they need to be able to fix these problems early in the development process easier? Is it going to give them information on which policies they're in violation of? Is it going to give them the line number in their code to know where they're wrong? And is it going to give them the kind of remediation guidance that they need so they can fix it quickly and just move on? Is the platform going to help them write the kinds of policies that you need at your organization? With choosing kind of a policy as code-based solution, you want something that's going to, be simple to use when creating simple policies, but also expressive enough that you can create sophisticated policies to cover any kind of use case that you have in the cloud. How learnable is the product? How desirable of a skill is it for your engineers to know this, to learn and know how to use this product? Is it something that they might be able to market for themselves out there, or something that you might be able to more easily find and recruit existing skilled engineers that already know how to use the framework, the tooling that you're looking at? A big part of that is it an open source policy as code language and framework? You'll find that the open source offerings that are out there are just much more attractive for engineers to be working with than some kind of black box proprietary language that might not be so transferable. Another consideration is, are we going to be able to use these same policies across the SDLC, our IAC checks, as well as our runtime checks? Or are we going to have to use and maintain different policies for those different stages in the SDLC? So let's get to implementation. And we're not going to dig in too deep here. This is sort of a little bit of view of what might be coming in the next, in a future masterclass. But what we want to look at is kind of your order of operations. Once you've asked all these questions, you've kind of done your selection analysis, and you're ready to move forward and implement your infrastructure as code security holistically, with all of your cloud security in mind. This is a general kind of order that you want to operate. Once you're going, this becomes a little bit more of a loop, but there's a couple steps in here that are kind of startup steps. The first thing you want to do is just bring all of your cloud stakeholders together. These are your developers, your cloud engineers, your security team, your operations, DevOps, compliance folks, and the business, your business leaders as well. Bring them together to kind of, again, answer a lot of the questions that we covered, and to start to kind of form a go forward plan for putting this in action. Next, you want to start small and pick a pilot. Is there a particular team running a particular workload in the cloud? Maybe it's a more security critical workload, and that's kind of a priority for you to get into compliance and improve your security posture. Start there, particularly if they're already using infrastructure as code, obviously a great place to start. Then you want to build out your policy library using policy as code, the framework and tooling that you've chosen. And these are going to include, whatever compliance requirements you need, what SOC 2, NIST, HIPAA, etc., as well as your internal security policies. And then you need to train your team. You need to hire to fill any gaps in security engineering that you might have. And essentially what you're doing is you're establishing that core expertise team, a team of experts in cloud IAC security and your particular cloud use case. And that will help you grow and expand and scale your security excellence across the rest of your cloud operations. Next step 5 is bringing your existing environments and your infrastructure as code into compliance. Prioritize, obviously, security critical at first and moving your way down. The bringing existing environments into compliance can be painful often, but if you have a tool that tells you everywhere that you're in violation and it's categorized by severity, you now have a roadmap to start bringing that into compliance, and you can measure your progress and report on it. You obviously want to build security into all processes. It's really what we're talking about, all the way across the SDLC. Developers checking their infrastructure's code as they're developing it so they can fix it and move forward. As that infrastructure's code is getting merged, going through CI/CD pipelines, you want automated guardrails there to flag vulnerabilities and maybe fail a build if it's a critical vulnerability, and then continuous monitoring and runtime remediation to catch anything that slipped through the cracks. And you want to measure everything, report on your progress, and eventually we'll get to optimizing this whole process for you in a future cloud security masterclass. But ultimately, what we're looking at with policy as code is bringing all cloud stakeholders, aligning them under a single source of truth with policy as code. There's no ambiguity about what the policies are, where they need to be applied. Everybody can apply. Everybody has the same understanding of what the policies are. They're embedded in our code, and everybody has access to that and can use it to help them do their work more securely. So again, future masterclasses, we want to dig more into that implementation process and how to optimize it to just move faster than ever before in the cloud and do so securely. Couple key recommendations, and I know we're a little over time, so I'll just zoom through this. First is use infrastructure as code everywhere possible. If you have certain environments with no IAC in place or just some IAC, try to get as much of that into IAC as possible. If you have IAC, you can evaluate it. If you're only operating in the console, that becomes very, very difficult. Obviously, you want to use policy as code everywhere that you can. You want to prioritize the needs of the developers. If you help your developers do things securely, you will be more secure. If the developer isn't central to your infrastructure as code and cloud security strategy, you're going to have a hard time. You're going to have a bad day. Consider the entire SDLC, the software development lifecycle, holistically when you're planning this. Don't just look at infrastructure as code security and we'll get to cloud security later. It really needs to be done holistically. Make sure you consider all your current and future requirements. And again, measure everything, keep optimizing. So a couple shout outs as you're making these decisions. For policy as code, definitely give a strong consideration to Open Policy Agent, or OPA, for policy as code. It's very popular in the Kubernetes community. There's a lot of support behind it. A number of big companies, Netflix, Capital One, et cetera, are standardizing on it. There's just a lot of great reasons to consider OPA as your policy as code framework. Fugue has our own open source policy engine that's built on top of OPA, specifically for checking infrastructure as code. This is free. You can grab it today, use it. It has a number of policies that are ready to rock. I think it's at the Fugue GitHub page, you can find Regula and check it out. So with that, I will close. We'll see if we have any additional questions. Just want to throw out there that at Fugue, we guarantee your success. Within 15 minutes, you will get a simplified and actionable cloud compliance assessment. That includes all of those, where you have vulnerabilities, a remediation roadmap for both IAC and runtime, guidance on every violation and how to remediate it. And you'll get, Josh kind of flashed some maps up there. You get these interactive maps of your cloud runtime for AWS, Azure, and Google Cloud, as well as your infrastructure as code, Terraform, CloudFormation, et cetera. And an understanding of your security posture, so you can start to put together the kinds of reports that you need and get those to management, auditors, your customers, et cetera. Reach out to sales@fugue.co if you'd like to get with some of our solutions engineers and learn how Fugue works and how it can help you in your use case. And Josh is always available at josh@fugue.co if you have any additional questions or just want to chat with him about your use case, or just ask him any questions. So thank you, everybody. I appreciate your time. This was fun, and it's kind of neat to be able to do part of it myself.